Hello everyone, today we're going to talk about version control systems, specifically Git. On a version control system, what it essentially does is allows us to save snapshots as we develop code and somehow manage that for us and make it available for the rest of our teams. The last iteration of this type of software that is commonly used in large teams in many corporations right now is Git. Git is a distributed version control system that allows us to all have full snapshots or a full history of the projects we're working on, which are called repositories, and make modifications locally, then save those modifications as save points and update a centralized location, whether that be a online Git repository like GitHub or particularly the company's Bitbucket enterprise accounts that is private repositories for source code that the company owns. I'll give a quick example in folder structures of how this is represented. I will create a folder called server, which will, for this example, represent a centralized location like GitHub, where we have all of our code. Now, we'll actually traverse into this directory and see that it's empty. So server's empty. We'll now create, using the touch command, a new file called codetext. Codetext is simply a file that will represent our source code in this example. When you are pulling down code from a centralized control version system like Git, what you do is you actually copy all the code that's available in the repository into your desktop. So it could be developer A's computer will now have all of the code that's on the server repository. In this example, we'll look at what the workflow is when a developer pulls down the code, makes a modification, and sends it up. So we'll open up the file and we'll add a new line of code in this file. And we'll show you what happens or how older non-distributed centralized control version systems worked. When you pushed up the file into the repository using the GUI or a control line interface program, command line interface program, we had the option of both keeping a version, which in the newer versions of centralized version control systems would allow you to have a history and have both the original code you worked on and a new version added. Now, usually some systems only modified it by creating a version number or hiding it or different strategies. Now, one of the problems with centralized control version systems is when you have multiple developers working on this. And now let's give an example of that. I will copy this into developer B's computer and have the files they have. Now, this file doesn't have anything because the latest version on the repository was blank. Now, what this version does is it will create a different line of code and possibly even more lines of code than the other developer. Now, when developer in a timeline, you could encounter this problem many times, is developer A pulled the latest code from server and has made a modification, but has not sent up the code back to the repository, saving it so that everybody could use it. Developer B, on the other hand, made different modifications and will do so by throwing the code back up. Where we had version control systems, we might have different versions up there, but older version control systems actually only replaced it, like in the case of SVN. We would replace the code, and now server has developer B's code. But before developer A was able to pull that, he changes or throws up his versions of code. And in SVN, you have the ability to replace. This will now create a big problem for both developers, which developer A may have lost part of the functionality needed from developer B because the one on server only contains his code. Developer B, on the other hand, has lost their code if they didn't have it saved locally. This is a problem with centralized version control systems. Although they provide some functionality by having a central location for developers to pull and update code, if one were to work on the same code, it will actually override the others, creating a conflict and possibly losing work. Now, what actually happens for centralized or distributed version control systems is we start again from an empty file. We'll create developer A developer B. A makes the modifications, a single line of code. And add a different line of code. Oops. And when B attempts to drop the code in here, it will actually keep both snapshots. And when developer A tries to update the code, it will also keep both. And the server will now contain all three versions, from the original code to the second developer's code, which was written before the second developer wrote his line of code. And tools like Git allow us to hold all these changes or modifications made to a single file within the same file. It hides away those changes in history in the background and provides you only a single file in view, if that makes sense. So I'll show you how this may work in real life. Now, for Git control systems, if you were to look up Git version control, this is the official Git documentation and where you could download if you don't already have Git on your computer. This is a great place for reading. The original developer for Git is, I'm not sure he mentions it here, but is Linus Torvalds, who created Linux. This is a big deal. He was one of the first large projects to be worked on as an open source project. This meant that he created code that many contributors around the world would actually pull down, make modifications, add changes, remove code, and then push them towards this centralized location. Because of how early in software development history this project took over, he was one of the first, or the Linux kernel community was one of the first large group of developers that encountered the problems and limitations with control version systems. This prompted Linus to actually create a new tool called Git that allowed us to have an easier way to manage very large projects, particularly with code, but they can be used for anything that has files, which includes design or any digital assets of any kind. Now, the official Git website also provides this book. It's free, it's online, and it teaches you everything from basic version control using Git to really advanced topics on how to create subcomponent modules and really complex branching schemes and other things I have no idea about yet. But if anything, my main point by showing you the Git documentation is that Git is a tool, not necessarily software or the GUI or command line, but just a type of program that enables you to have control systems. Now, the next part, which is one of the more famous projects using Git, is GitHub. GitHub is a community or place where people upload their code and share it. And using the Git program, you're able to contribute, pull down, copy, modify, and share that modified code with a lot of other people. I'll log in. And I can show you projects. So many large corporations like Facebook, Google, React, frameworks, Python, a lot of projects are actually hosted on this website. So this probably is the largest code repository online. And one of the easiest parts about it is how open it is. You can actually jump into, like, let's look for Google code. If I were to do, this is the official Google users open repositories. I'll look for JavaScript. So They currently have 136 repositories just dedicated to JavaScript. I want to see their... Let's look for Polymer. Now, if you haven't heard of Polymer, Polymer is Google's project, and it tries to modernize web components using scaffolding and JavaScript. So this is what a typical repository's main page will look like. It will give you folders and files, the exact source that's contained in the repository. It will also have documentation based on these README files, and you'll be able to kind of just go in and look for source code. Now, one of the important parts of Git is there's a workflow for it. There's a couple of important commands. The main one is git commits. That's how you actually save those snapshots, like those save points while you develop. There's git push and pull, which, as the name suggests, is either pulling the code from the centralized repository like GitHub, or pushing the code back up to GitHub with the modifications you've made. And the other one's clone. So clone is how you are able to pull down and have all of the history associated to that repository at that point. So I will actually show you what that looks like. Using HTTPS, you can grab the link of where the code is. In this case, it's under GitHub. And going into terminal, I will go into the desktop and do what is a clone command using Git. So it's git clone and then the address of that location for the repository. And this will actually pull down, start cloning the Polymer project, and brings down all the assets, the source code, and all the files. So if I look into this, we should be seeing the same exact files and source that would be listed on the repository online. So if I were to go into images folder, I would see this migration PNG. I have that migration PNG now in my computer, and this is the biggest helper to software developers, being able to share, pull down, and have that code. If I wanted to make a modification, I could go in and change the README to have, actually, I can open this with text edit. I can call this James Polymer. And now I've essentially, in a very minuscule way, modified the repository, added a change in, and I could push it back up. It would be very unlikely that they would allow this pull request to be adopted into the main source code, since it's useless. But that's the essence of Git, being able to pull down, share code, make changes, and save them. In the next video, I'll show you exactly how all the workflows from the command line to be able to use Git. But first I wanted to show you the idea of what it is. Thanks, guys.